Hi, my name is Mr. Gcse from Gcse Education. In this video, I'll be going over ionic bonding. Let's start with what is an element. Elements are made of one type of atom, whereas compounds are made of more than one type of atoms. The elements are placed in a periodic table. They are metals mainly on your left hand side. The metals are mainly on your left hand side, whereas non-metals are on your right hand side of the periodic table. In another video we go over about periodic table and etc. The compounds are made of more than one type of atom, but the bondings between atoms, you can make bonding. So metal and non-metals make ionic. This is the one I'm going to go over today. In the next video, covalent and metallic. So ionic bonding, metals loses electron. In this one, I took sodium as an example. So when sodium loses electron and the electron is transferred to the non-metal chlorine atom, so chlorine gain electron. When sodium lose electron, it becomes sodium plus ion, whereas chlorine atom gain electron to become chloride negative ion. So between the negative and positive ion, a strong forces of attraction is called electrostatic forces of attraction take place between oppositely charged ions. These ions are placed in a layer of lattice. Another word for that is a giant ionic. So this giant ionic is ions are placed in alternate way, positive and negative and etc. So because lots of positive and negative ion are arranged in a layer of lattice, it's required lots of heat energy. Lots of heat energy to overcome the electrostatic force. For that reason, it has a very high melting point. And they do not conduct electricity when it's solid. Make sure you must say the word free movements of ions. There's no free movements of ions. If you say electron here, you lose the mark because electrons are already transferred. And again, another point you can say, ions are fixed in position, they do not move. So that's the main mark. But when molten, that means in liquid state, ions are free to move. One point, therefore is conduct electricity. In solution, also ions are free to move, therefore conduct electricity. So let's try an exam style question now. The sodium chloride in a 3D structure given to you, which is the melting point is 801. The question number 1 is simply balancing equation. You would have practiced a lot of balancing equation. So I'm going to simply put 2 in front of it to balance the 2 lots of chlorine here. Therefore 2 in front of it. Sodium is a metal solid. Chlorine is a simple covalent compound. It's a gas. And sodium chloride is an ionic compound, it's a solid. That's 1 mark. Pretty straightforward. The next one is they ask you, sodium chloride has a quite high melting point. Again, you have to talk about the strong electrostatic forces of attraction between ions. Therefore, you need lots of heat energy to overcome the forces. So that's your second mark. The next question, in molten state, when is heat, the molten state take place. So there's important thing, increasing heat mean increasing kinetic energy, therefore vibration increase, right? So increase vibration of the ions, and then therefore on heating, therefore ions have sufficient energy to overcome the attractive electrostatic force. They can move around. So that's 2 marks. So you need to give these 2 main points here. Okay, so you need to give these 2 main points. The next one is molten sodium chloride will conduct electricity again. Ions are free to move is a key word. The next one, they're given to you again 3D sodium is a positive ion, whereas chloride is a negative ion. So the question is, when it's solid, sodium chloride will not, before that, explain why the ions in this lattice stay in place. So you need to give this all the points. So negative and positive ions are arranged in alternate way in a layer, and again you have to explain very clearly that the forces are in all directions. So if the negative ion of the chloride is, there's a force there, there's a force there, there's a force there, there's a force there, there's a force in all direction. Okay, that's the point you have to go back, get your 3 marks. And the next one is pretty much same question. In solid state, it doesn't conduct electricity. Again, there's no free movements of ions, and in molten state, right, ions are free to move, therefore it's conduct electricity, etc., etc., right? And the next one, another form when other than molten is when dissolved in water. The equation I given you here, sodium chloride solid, when you dissolve in water, is become a solution or aqueous form. That's a solution, right? The solution, that means the ions are free to move. Ions are free to move. Again, I say, do not say the word electron in here, right? So, right. So these are about 11 mark questions going over with you guys after giving you the summary notes of ionic bonding. Similar question and answers, if you needed it, please contact us. This is our email or visit our website. The next video all about covalent bonding. If you have any further questions, please contact me directly or email to my admin. Thank you for listening.